Hello and welcome to Chapter 2, Section 2. We've just been talking about the difference between chemical versus physical changes. Now, changes in state we're going to talk about specifically. These are physical changes, and we're going to get into some of the vocabulary as we transfer from one state to the other. Changing states does not change the substance. It only affects the temperature and the thermal energy, how fast the molecules are vibrating. It doesn't actually change the substance. For example, water, when it's liquid, vibrates like this. When it's solid, it vibrates enough that it can connect. When it's steam, it vibrates so much, but each of these molecules is still H2O. Does not change the substance. Now, as we're moving from solid to liquid and from liquid to solid, we need to understand that specific point. We call that melting. I know it's a difficult term, but bear with me. Melting is exactly when a solid becomes a liquid. And the melting point is that exact spot, the lowest temperature a substance can be and just start to melt. It is no longer a solid. As the solid heats up, the particles vibrate faster. So you're a solid, but you're still connected, but you're still vibrating. And as it heats up, the vibrations break loose. You can't hold on anymore. Then they slide past each other. And that's actually melting. Substances have very specific melting points, like iron and ice, and some get softer gradually. They can, like plastic and chocolate, they get softer and softer, and then they actually start to become an actual liquid. Let me move my little thing out of the way, and you can see my happy little picture of wax. Wax is another one that gets softer gradually. Then we have freezing. Freezing is the opposite, when a liquid becomes a solid. Many things, look around you, many things are solid at room temperature. Metal and wax, those are they've passed their freezing points. They've passed the spot where they will just become a solid. Whereas something like ice, you have to get a lot colder. The definition of freezing is when particles lose enough energy to break away and they become fixed in their crystal structure if they have one. The freezing point is the temperature at which a liquid becomes a solid. Freezing melting points are the same depending on which direction you're going. If you're going up and you're getting warmer and warmer, then that's your melting point. And if you're getting colder and colder, then that's your freezing point, but it's the same point. This is a characteristic of the substance and can be used, hang on, I lost my thingy, to identify it. And now I'm going to have some happy picture behind my little picture. And here are two penguins talking about, wonder what this stuff is. Yes, it's snow. Duh. If you've got a metal and you're not sure what it is, you can actually say, oh, well, I know that the melting point of iron is this, and the melting point of, quick, name another metal, aluminum and tin, and this one's this, and this one's this. And so, okay, let's get this really hot. And you can actually say, oh, it melted at this point, it must be that metal. So you can use it to identify the substance. Then we have liquid-gas relationships. Evaporation is when a liquid becomes a gas at the liquid's surface. So only at the surface of the puddle or the glass of water, if you've got a glass filled with water or something, only at the surface will there be enough energy for those molecules to speed up and escape and become a gas. The fast-moving particles near the surface can break away from the liquid and become gas. But it only happens at the surface. And that's usually because the energy from the atmosphere adds to the amount of energy the molecule has. And as the temperature goes up, the particles vibrate more and they escape faster. Now, check this out. This is a puddle. And all of these are water molecules. And just at the surface of the puddle, this is where just a few of those molecules get enough energy, additional energy, to vibrate fast enough to escape. This is evaporation. It only happens at the surface of the puddle. Then we have the boiling point. This is the specific point, the temperature, where liquid becomes gas. And this forms bubbles. So you know it's boiling if it's bubbling. And this can change with elevation just because, remember we learned about Boyle's law and Charles' law and Bob, the unnamed law, who the amount of pressure changes how temperature affects gases. So anyway, you don't have to remember that part. Just remember it can change with elevation. Thermal energy of particles is high enough for the particles to bounce away. And they bounce inside the liquid. They're inside and they're bouncing so much, they've got so much energy from the heat source on the bottom that they start bouncing way down at the bottom of the liquid, and that's what makes the actual bubble. There's the little guys bouncing in there so far that they're bouncing everybody else out of their way, and they're creating an actual space of air. And I'm in the way again. So here's the space of air that these guys they're bouncing so fast that they're bouncing everybody else out of the way, and this makes a bubble inside the liquid. And of course this is lighter weight than all of the particles around it, so it's going to rise up. Then we have what's called condensation. This is turning a gas into a liquid. So do I explain this? Let's see if I explain it. When a gas touches something cold, the particles lose energy and become liquid. And this happens a lot on the side. Oh, I'm bad at this. On the side, I have a science cup. Check that out. On the side of your glass, if your glass is filled with ice, then this is cold. Now, in the air around us, there's water vapor all the time. And so there's little air molecules floating around, and they bounce off things and they bounce off things, and then when they bounce here, they actually touch this and they get colder. If this is filled with ice, they get colder and they lose all of the energy that made them bounce and be a gas, and now they're stuck here and they're a liquid now. And so your condensation, when you have a soda or some kind of a big iced drink, the stuff that's on the outside is not anything that's come out. It's actually pure water from the atmosphere. Often seen on the side of a drink glass. And let me move myself out of the way again so you can see condensation. Yes, because I know that you were very interested. And then we have solid to gas. So this word is sublimation. This is a vocabulary word, so highlight it or whatever you're going to do. When a solid changes directly into a gas, it skips the liquid state completely. This happens when the melting point and the boiling point are very close, if not identical. And this doesn't happen with very many elements at all. In fact, very, very few can actually go through sublimation. Sometimes water can, but special cases. But for the most part, carbon dioxide is one that goes straight from a solid, which is dry ice, straight into a gas, because the melting point and the boiling point are the same. Look, you don't have to write that down. Just write down carbon dioxide and dry ice. So, and I have a cauldron. And okay, so when you come back to class, I need to see these notes. I need you to underline and or highlight all of your vocabulary, and you'll take a clicker test when you walk in. So Thanks for doing your homework. Have a good one. I'll see you soon.